Alright guys, so we're going to get started with these notes here. We have velocity versus time notes. Okay? The first thing that we're going to want to do is draw a velocity versus time graph. So you can see right here I'm drawing that graph. I'm going to label my axes. On my y-axis I have velocity, and I'm going to give it the units of meters per second because those are the units that we're going to use in class. Then on my x-axis I have time, and the units seconds. Alright, so now I'm going to label a few data points on this graph. I'm going to have the 0, -2, -4, +2, and +4 for my velocities. So the velocity versus time graph is going to tell us a few things. We're going to figure out exactly what it's going to tell us in a sec by looking at a couple of examples. So we'll look at examples where we're above the axes, below the axes, all that good stuff. So the first one we're going to start with is what I'm drawing right now. That's going to be a horizontal line starting at a velocity of 2 meters per second and continuing at that velocity. So if we look at the graph real quick, we can see that for example 1, our slope is just 0. Okay, so when I'm saying no slope there, what I really mean is that we have a horizontal line with a slope of 0. What does that mean though? That's going to tell us that we're neither speeding up nor slowing down. The reason is that if we look at our graph, we see that our velocity is maintaining 2 meters per second for the duration of that time, which means that we have a constant velocity, right? If we're not speeding up or slowing down, that's going to result in a constant velocity. The other thing I want to talk about is where this line is on our graph. We can see that this line is on the positive side of our graph, right? The velocity has a positive value of 2. So since it's a positive value there, we're going to classify it as moving away from the origin. Now that we've handled a positive example of velocity, we're going to do the same thing, but we're going to try looking at a negative example of it. So same exact line, we still have a horizontal line, but this time we have a negative velocity, and that value is -2 meters per second. Approaching this problem just like we did before, we're going to recognize that a horizontal line is telling us that we're neither speeding up nor slowing down. Like we said before, when we're neither speeding up nor slowing down, that gives us a constant velocity. And if we're looking at the graph, we can also see that this line is on the negative side. It has a negative value here. So that's going to result in us moving towards the origin this time. So if we take a second to think about moving towards the origin, we can see, right, that our speed or our velocity is -2 meters per second. -2 meaning that every second we are losing 2 meters. The only way we can lose meters is if we're moving towards something. We're going to look at another example here, example 3, where we are also starting above the x-axis, but this time, as you notice, we have a sloped line. We'll talk a little bit more about that slope in a sec, but the thing I want to point out, and I want to start every problem with this, is how we have a positive value here above the x-axis. That positive value is going to result in moving away from the origin. The way that we know that, right, is that we can see that we have 4 meters per second, so we're gaining 4 meters every second. Now we're going to talk about the slope. We can see that we have a negative slope here, right? We're going from positive 4 meters per second down to 0 meters per second. What is that negative slope going to tell us? Well, that's a good question. The negative slope is telling us that we are slowing down in this case. In other words, it's that we are becoming more and more negative. So our velocity is starting at 4 meters per second, and it's making its way down to 0 meters. So here's our last example above the x-axis. We can see that we're starting at 0 meters per second, and we're ending somewhere around 4 meters per second. The first thing I want to note, and like I mentioned, is that we are above the x-axis, meaning that we have some positive value of velocity. Because of that, we're going to classify it as moving away from the origin. Like we said, our value goes from 0 to 4 meters per second. Those positive meters per second means that every second we're getting further and further away from that origin. The last thing we want to look at is the slope of this line. We'll notice really quickly that we have a positive slope. We're starting at 0 meters per second and we're ending at 4 meters per second. The slope is going to tell us that we are speeding up. And by speeding up, we just mean that our velocity is becoming more and more positive. Positive slope is going to mean a positive acceleration. Alright, so I'm just going to clear up the space really quick, and we're going to take a look at our last two examples. So these examples are going to be um, very similar to the lines that we had before, except under the x-axis. The first line that we want to start with is number 5. So we're going to walk through the steps just like we did before. The first thing that we want to notice is that we have a negative value for this velocity. We're starting at negative 4 meters per second and we're ending at 0 meters per second. That negative value is going to tell us that we're moving towards the origin. The next thing that we want to notice is that our line is actually sloped upward, meaning that we have a positive slope here. Like we said before, a positive slope is going to indicate that our velocity is becoming less negative. In other words, our velocity is becoming more positive. A positive slope also translates to a positive acceleration. We're going to draw our last and final example here. This is going to be line number 6. So for line 6, we see that we're under the x-axis, which means that we have a negative value for our velocity, right? We're starting at 0, ending at around negative 4. We've said before that that negative value is going to mean that we are moving towards the origin. And then the next thing we want to note is that we have a negative slope. So just like we said before, a negative slope means that our velocity is becoming more negative. All right? A negative slope also is going to mean a negative acceleration. Now that we've gone through various examples, I just want to go ahead and summarize all the information that we've talked about thus far. So first I want to start with looking at what happens if our velocity is above the x-axis. Well, we can clearly see that from the examples from before, any velocity that's above the x-axis, so any positive velocity, is going to result in moving away from the origin. Like we said, a positive velocity there means that we are gaining meters, and we are gaining meters away from the origin. The next thing we want to look at is below the x-axis. And below the x-axis, we can see that we're moving towards the origin because we have a negative value for velocity. A negative velocity means that we are losing meters, right? Negative meters per second. So every second we're getting closer and closer to that origin. Next, let's take a look at the slope. So a positive slope, what does that mean? Well, a positive slope is going to mean that we have positive acceleration. And like we said before, what does positive acceleration mean? It means that our velocity is becoming more positive. Now let's take a look at negative slope. Well, negative slope is just going to be the opposite of everything that we just said. Negative slope is going to have negative acceleration, and that means that our velocity is becoming more and more negative. Now that we've talked about positive and negative slope, it's time to talk about a horizontal line, because a horizontal line is neither positive nor negative. And because it's neither positive nor negative, that means that it does not have any acceleration. So if there is no acceleration present, that means that we have a constant velocity. If we're looking at our graph above, we can see that on lines 1 and 2, that those are horizontal lines. If we read the graph, we can see that our velocity for line 1 is 2 meters per second, and that doesn't change during the duration of our graph. Same for line number 2, our velocity is negative 2 meters per second, and that doesn't change either throughout the graph. Putting all that together, what does that give us? Well, we can infer that from this given information, the slope of our velocity versus time graph is actually giving us our acceleration. Therefore, we could say that acceleration is the change in velocity over time, which, like we said before, is just our slope. Alright, and that will conclude our notes for velocity versus time.